do the indicated operations and simplify if possible. Here we have two rational expressions that we'd like to subtract, and they have different denominators, right? We have an x there and a 2 there. If we want to subtract things with different denominators, say 1/2 minus, say 4/5. If we wanted to do this subtraction, what we would have to do first is get a common denominator. So we'd look at 2 and 5 and we'd say, oh, if I multiplied the 2 by a 5, I'd have a 10 in my denominator. If I multiplied this 5 by a 2, I'd have a 10 in this denominator, and then I'd have the same denominator, so I could do the subtraction. Okay, so how can I multiply by 5? I just can't just do it, right? If I multiply by 5 down here, I change the problem. But if I put a 5 in the numerator as well, what's this thing? That's just a fancy way to write the number 1, right? 5 divided by 5, 1. So I'm multiplying the whole thing by 1. I'm not changing anything. So in order to multiply in the denominator by 5, I had to multiply in the numerator by 5 as well. Same thing here. In order to multiply in the denominator by 2, I can go ahead and multiply in the numerator by 2. And again, that's just a fancy way to write the number 1. So I'm multiplying by 1, not changing anything, except I am changing the way that it looks. So instead of a fraction with a half in it, with a divide by 2, I'll have a fraction with a 10 in the denominator. Right? In the numerator, I'll have 5 times 1, 10. Here, in the numerator, 4 times 2, 8. In the denominator, 10. Subtracting fractions that have the same denominator, I just subtract their numerators, put them over that common denominator. 5 minus 8 is negative 3. Right? So negative 3/10 is how to do this subtraction problem. Get a common denominator. Well, here, rational expressions, same thing. Let's get a common denominator. So I look at my denominators, 2 and x. They don't have a common factor, so I just want to multiply by my 2 by an x and my x by a 2, right? And then I'll have a 2x and I'll have a 2x. All right, and just like with the numbers, if I want to multiply in the denominator by a 2, I need to multiply in the numerator by a 2, so that I'm multiplying by this fancy version of the number 1. Same here. In order to multiply my denominator by an x, I got to multiply my numerator by an x too. So I have this fancy version of the number 1, something divided by itself, multiplying by 1, not changing anything. All right, so let's do that. Multiply in the top by 2. 2 times 3 is 6. Multiply in the bottom, I get a 2x. Minus, multiply on the top by x. 5 times x. X times x. The bottom, 2x. Now I have the same denominator. All right, so I subtract 6 minus this numerator. Got to subtract the whole numerator. So minus 5x and then minus a negative x squared. Minus a negative, so plus x squared. All over 2x. All right, we can go ahead and try and factor this thing. If this factors, I need to find factors of positive 6 that add up to negative 5. All right. And so negative 3 and negative 2 work nicely. 2x in the denominator still. Look at my factors. Are there any common factors? No. So this does not simplify any further. And that can be our final answer. If you wanted, you could leave that as your final answer as well. Nothing simplified, so this is just as simplified as that. This is in factored form. This is not. Well, it's your choice. What do you want to leave? But either form works. It does not simplify. So we're done.